So similar to the previous video, but this time we're going to try and find out the derivative of cos of x instead of sine of x. I'm going to assume that you know these identities here, but this time, because we're trying to work out the derivative of cos of x, we're going to use this identity here. In the previous video, we used this one here, but in this video, we're going to use this one here. Remember, it's going to be cos minus sine. Just bear that roughly in your mind, okay? And from our section on limits, I'm going to assume, we're trying to ingrain this inside your mind. The limit of this is 0, and the limit of this here is 1. Okay, try to remember these two limits here. Very important. Okay, so again, if we are trying to find out the derivative of cos of x, so start out by drawing your graph. So your cos of x will look like this. Your graph cos of x will look like this. Set up 2 points A and B here, and then the gradient that exists between A and B is when you start to take the limit as h tends to 0. So just as normal, set up 2 points A and B, and then get h here to head towards 0. So that will then take us to this here. And then use the identity above, where if you have cos of this, remember it's cos minus sine. That's this thing here. Hang on, that's this thing here. We are using this identity here. Remember, it's cos minus sine. Okay, so it's us using that. Hang on. So when you're here, it's cos sine. So this thing here, this block here becomes this. Okay, and then you've got your minus here. That's this minus here, and then you've got this block here. So that's this block here. Okay, so that will then take us to here. So now visualize as what you've got one block, taking away this block, taking away this block here. Switch these two around. Here. Okay, so now you've got this block, take away this here. And then break up the fraction. So it's like this. Break it up like this. So you've got one fraction here, taking away this fraction here. Okay? And by the way, the minute you break up this fraction here, you've got to have brackets. You've got to have these brackets here. Otherwise, if you don't, it will look like this. Hang on. It will look like this. If you don't have these squared brackets here, it will look like this. And people, when looking at this here, people will think, oh, you're just taking the limit of this, and then this is something separate. So you've got to have squared brackets around here. So the minute you break up this fraction here, you've got to have these square brackets. So you're taking the limit of this whole thing here. Okay. Well, anyway, break up this fraction. It will then give you this, and then what? Hang on. And then and then factorize the cos of x is in common here. Cos of x is in common here. Factorize the cos of x, because if you get this multiply this multiply this, it will then give you this whole thing here. So basically, factor out the cos of x here. Okay, that will then give you this, and then this thing here. So now you rather than you finding out the limit of this whole complicated thing here, just concentrate on finding out the limit of this, and then so that's this bit here, and then concentrate on finding out the limit of this. So that's you finding out this bit here. Okay, so so that will then take us to here, and then h here is you're taking the limit as h tends to 0, and this thing here doesn't really contain h, so you can actually take it out. Okay, same with over here. Doesn't really contain h, so you can take it out here. Okay, and again, I forgot h tends to 0 here. Okay, so that then gives you this, Okay, so you've got this thing multiplying with this thing here. Take away this thing multiplying with this thing here. And by the way, the limit of this here is 0. The limit of this here is 1. Okay, so you would then have this. So this here would be 0, and then this here would be 1 here. So it would then become, well, this cos of x times 0, that's 0, leaving you minus sine of x here, leaving you this, minus sine of x. So the derivative of cos of x, is simply minus sine of x. Okay, and this here, you must ingrain this inside your mind. You have to know this by heart. Okay, very important. So memorize this. The derivative of cos of x is minus sine of x. So when you look at the graph here, remember we are trying to find out the derivative of cos of x here. So now keep an eye on the blue line, because the blue line is what we're talking about, cos of x. Now the gradient of cos of x here is 0, and you can see that here. Remember it's sorry, it should be minus sine of x here. Well anyway, yeah, draw your own graph and then you can see it for yourself here. Suppose you're at this point here. Let's say this point here. The gradient here is negative 1. So the gradient of cos of x is negative 1. And if you look at the sine of x here, if you the sine of x is 1, but then if you have minus sine of x, it will be negative 1 down here. So it corresponds with this. So the gradient here is really minus 1, because sine of x is normally 1 here, but then if you have minus sine of x, it will be down here. Okay, if you look at over here, the gradient of cos of x is positive 1 here, but the normal sine of x is minus 1, but then if you have the negative version of sine of x, it will then jump up to here, giving you a gradient of positive 1. So the gradient of cos of x at this point here is positive 1. Okay?